Right, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to explain further on the what we call the program execution. All right, for chapter 3, this one, the video for this I have uploaded and I believe that you have watched the full video for the chapter 3. But for this video, I'm going to emphasize on the program execution. Right, so we go straightly to the slides for the program execution. But before that, maybe I can emphasize or maybe can have a revisit for the computer components. So in the computer components, this is the basic one, whereby you have the CPU, you have the input-output module, and you have the main memory. All right, let me change color first. In the CPU, there are several register or the temporary memory. Okay, so it called program execution. It is called as instruction register, uh, MAR memory buffer, um, sorry, memory address register. We have the memory buffer register, MBR, and so on. So these are the registers or the temporary memory in the CPU. And in the input-output module, it also has buffers, okay? And the main memory is the memory itself, okay? And it has the system bus. And these are the system bus is the component to transfer all the data either to the CPU, to the main memory, and to the input-output module. Okay. Right. So basically, the explanation for each of the component, this one has been explained in the previous video. Okay. So we go to the this one, basic instruction cycle. Okay. So this is the basic instruction cycle, whereby it has the fetch next instruction, and it also has the execute instruction. So this is basically is the basic instruction cycle. So it's going to start, okay, it's going to start, and then the CPU or the computer, okay, it will go for the fetch next instruction. Okay, so we are going to go detail for the program execution for you to understand this basic instruction cycle, and then it will execute instruction cycle. Okay, um, and this one will be iterated until the instruction completed. Okay, after instruction completed, it will stop. Okay, the process. So this is the basic instruction cycle, and basically it involved with several memory. Okay, either the what we call the CPU memory, the main memory, and also the input output module. Okay. Now we go to this one. Okay, the instruction format. For this instruction format, okay, it consists of the opcode and also the address. What does it mean by opcode? Opcode, okay, opcode is the operation code. Right, opcode is the operation code, and the address belongs to the specific address for the instruction. Okay, so this is the operation code. What basically contains in the operation code? It can be the arithmetic operation. Okay, for example, the addition. Okay, it can be multiplication. It can be subtraction, division, and so on. Okay, so this is the example of the operation code, and it can be also the logical operation. For example, the XOR. Okay, and what else? And or, okay, and others. All right. So this is basically the operation code. Okay. All right. And the address is the it comes from the either from the main memory, okay, it can be comes from the input output memory, right? The address. Okay, so the instruction format, it contains the opcode and also the address of the memory. Okay, so if you see for this format, for this instruction format, it starts from 0 until 15 bits. So meaning that this is 16 bits of instruction format. And for the operation code, it contains from 0 until 3. Okay, 0 until 3. So meaning that for this operation code, it consists of 4 bits. Okay, 4 bits for the operation code. Okay, so the rest, 12 bits, another 12 bits, this is for the address. All right, so this is the instruction format, and now this is the integer format. Okay, so integer format, it depends on the number. Okay, it depends on the number. However, it has two area here. This is 1 and this is 2. Okay. For this one, basically it contains the sign bit number. Okay, sign bit number. Okay, and the magnitude is the number itself. Right? So the sign bit number, this is where it will indicate whether the number is positive or negative. Okay, positive or negative. All right. So for the bit, we only have 1, 0, and 1 only, right? So there are 2 bits. Okay. So for the sign number, okay, sign bit number, it contains either one, okay, either 0 or either 1. All right, so for positive numbers, it will be 0, and for negative number, it will be 1. All right, and the magnitude, this is the what we call the number itself. So now let's see the example. Okay, let's see the example. Right, so this is for the sign bit number, and this is for the magnitude for the number itself. All right. So now let's have a look at the positive, um, positive 5. Right. So since this is positive, so the sign bit number should contain bit number 0. So inside here it will contain 0, and the magnitude itself, okay, the magnitude itself, uh, it is number 5. So number 5 in binary, it is 0101. Okay, and you must know how many bits. Yeah, okay, how many bits for the magnitude. In this example, I put it as 4. Okay, but you can it can be 12 bits number, it can be um, 16 bits numbers, and so on. Okay, but for this example, I'm taking 4 bits for the magnitude, okay, and 1 bit for the sign bit number. And for positive 5, it is 0, and for the magnitude is 0101. Okay, all right. Okay, now before we go for the program execution, program execution, so let's see what does it mean by PC, what does it mean by IR, and also the AC. All right, PC is the program counter, and this is the address of the instruction. Okay, address of the instruction, and IR is the instruction register. All right, instruction register, and the role of instruction register is to hold, all right, instruction that will be executed. Okay, and for the accumulator, it contains it is the temporary storage. Okay, so this is where the operation will be um, will be handled. Okay. Um, all right, will be what we call will be operated inside the accumulator. Okay, so this is the internal CPU registers, contains PC, IR, and also the accumulator. All right. And now let's see the partial list of the opcodes. Right, since the computer only handles bit or binary numbers, okay, um, and we, the human, we are normally familiar with the decimal numbers, okay, and the program execution basically we handle the decimal numbers, but actually the computer um, it only familiars or it only hold the binary numbers. All right. Okay. Now for the opcode, it has the loading. Okay, from loading the accumulator from memory, and then it has the storing part. Um, store from the memory to the accumulator, and then the operation, and this is the addition to the accumulator from the memory. And we see the binary number here. Okay, we see the binary number here. So this is 0001. So 0001, this is in binary number. Basically, in the decimal, it is number 1. Okay, for 0010, okay, in decimal, it is number 2. And 0101, in decimal, it is number 5. All right. So you already know that this operation code belongs to number 1. Okay. This operation codes, the storing part belongs to number 2, and addition 0101 belongs to number 5. Okay. So we just convert from the binary to the decimal numbers. Okay. And these are the operation code. Okay, so you already understand the internal registers in the CPU, okay, and you already know what are the operation code that need to be done in the program execution. Okay, now we go to the program execution. Okay, we go to the program execution. So we have memory here, okay, main memory, and we have the CPU registers. Okay, remember what involved in the CPU registers? It consists of the program accumulator, instruction register, and also the accumulator. So we have PC here, we have accumulator, and we have the instruction register. All right. So what actually the PC? Okay, what actually PC? PC contains the address, okay, address of the instruction. So the first address, okay, the first address that need to be executed is 300, okay, 300. So meaning that the address of the memory that contains the instruction should start with the 300, right? Okay. So here, all right. So remember the instruction format. The first part is the operation code, and the second part is the address. Okay. So the same thing here. The first part is the operation code, and the second part is the what we call the address. Okay, of the instruction or the address of the data. Right. Now, in the 300, it contains, okay, 1940. So 1 is the operation code and 940 is the address. Okay, is the address. All right, now we already know what is the operation code. So this one, okay, uh, okay, before that, this 1940, okay, after we know that the program execution contains address of the instruction 300, so it will look at this instruction this address 300. So inside 300, it has 1940. 1940 will go to the instruction register. Okay, instruction register. What is the meaning of the instruction register? It is the instruction that will be executed. Okay, instruction that will be executed. So this one, okay, this one will go into the instruction register. Okay, 1940. Right. So now the computer will try to interpret. Okay, will try to interpret the instruction register, the number inside the instruction register. So it contains one. Okay. So what does it mean by one here? Okay. What does it mean by one? Okay. What does it mean by one? So one, okay, if we refer to the operation code, it is the loading instruction. Okay, this is number one, loading instruction. Loading uh, numbers or data from the memory to the accumulator. So where's the memory that contains the data? Okay, where's the memory that contains the data? The CPU, okay, will try to find the address of the memory. Okay, the address of the memory that contains the data. So the address is 940, right? 940. So number one is the loading, okay, the data inside 940 address to the accumulator. So where is 940? This is 940 and inside 940 it contains number 3, okay, 0003. So this 003 will be will be loaded into the accumulator. All right, will be loaded into the accumulator. So number 3 here will go inside the accumulator. What is the accumulator? This is the temporary storage and all the operation will be conducted here, okay, in the accumulator. All right, so this is the first and second step of the program execution. Now we go to the next one, okay, PC. Okay, once it's being executed, once it is done with the execution, the PC will increment one. So it is now 301. Okay. Now the next step, the next step, program counter contains 301. What does it mean? Okay, 301. So 301 is the address of the instruction. Okay, address of the instruction. Now 301, the computer will try to find the address 301, and inside 301, it has instruction 5941. Okay, 5941, and 5941 will be go to the instruction register. Will be loaded into the instruction register. All right. So now, okay, inside the instruction register, it has 5941. Okay, again, the CPU, okay, the computer will try to interpret the operation code 5, number 5. Okay, so what actually number 5 instruction? So you can see that from the opcodes here, number 5, okay, 0101 basically is to do the addition, okay, to do the addition, okay, in the accumulator, okay, add to the accumulator from the memory, okay. All right, now it will do the addition, but to add with what numbers? Before this, we have number 3 in the accumulator, but what actually the addition numbers? Okay, what actually the addition numbers? 3 plus what? Okay, so now it will go to the, it will try to retrieve what data, okay, what number that should be added. So now it will go to the CPU will try to find the address, okay, of the memory that contains the data. So the memory address is 941. So 941 here, okay, 941 here, uh, the data is number 2. All right. So the operation here is to add number 3 from the previous from the previous accumulator, okay, with number 2, okay, with number 2 from the memory 941. Okay, so 3 plus 2, okay, equals to number 5. All right, so this is basically the operation that handled by human. But in computer, this is not the um, exact operation or the exact method, okay, conducted by our computer or by the CPU. Okay, remember that our CPU only handles binary number. Okay, so basically, what happens to our computer is it will be the addition is in the binary numbers. So number 3, okay, in binary is 0011. All right, and for number 2, okay, in binary is 0010, and it will do the addition. Okay, so 1 plus 0, 1. Okay, 1 plus 1, this one 0, carry 1, and this one 1, and this one is 0. Okay, so we have 0101 here, and 0101, when you convert to the decimal numbers, it belongs to number 5 in the decimal. Okay, so this number 5 will be actually inside the accumulator after the addition process, right? And the PC will be incremented 1. Okay, so now the PC is 302, right? So done with these processes. Okay, so next we are going to see the next process whereby the PC, okay, whereby the PC contains address 302. Okay, the instruction is not meaning that the process is not completed yet. Okay, the computer will do the process iteratively until it is completed. Now the PC, okay, now the PC incremented 1, so it becomes 302, so meaning that the process is not done yet. Okay, so now we go to the address 302. Okay, address 302, so it contains instruction 2941, and these 2941 will be inserted inside the instruction register. Okay, I repeat, the program counter contains 302, and 302 basically the address, the memory address contains the instruction. So the CPU will find address 302, and inside address 302 it contains information or the instruction which is 2941, and 2941 will be uh, or will be inserted inside the instruction register. All right. Again, our CPU, okay, again, our CPU after the instruction inserted in the instruction register here, it will do the interpretation for the operation code, okay, and the operation code inside the instruction register or inside the instruction itself is number 2. Okay, so this one, number 2 here, okay, if you go to the opcodes, okay, if you go to the opcodes, number 2, the operation is to store, okay, to store the number inside the accumulator to the memory. Okay, number 2, the operation code is to storing, okay, numbers inside the accumulator to the memory. Okay, now it will basically store these numbers, okay, number 5 inside the accumulator to the address, okay, to the address, what we call to the address in the memory. Now, where is the address? The address is 941. Okay, the address is 941. So the computer will find the address 941. Okay, and these numbers, okay, these numbers will be inserted inside this address. Okay, 941. So inside 941, before this, okay, before this is 0002. So when the instruction to store the number, okay, the data from the accumulator to the 941. So it will be overwritten, okay, overwritten, the address overwritten from number 2 to number 5. It will overwrite, okay, the numbers. All right. So this is the operation or the program execution, the explanation of the program execution. With that, thank you very much. Assalamualaikum.